So let's take a look at one sort of setup thing that we'll need to know about before we start combining Box2D and SFML, and that's the conversion. If we take a look at Box2D, it uses meters to represent the positions of things. So we can have an object sitting at 1 meter and 2 meters on the 1 meter on the X and 2 meters on the Y, and that's fine for our physics simulation. It knows exactly what to do with those values. SFML, on the other hand, uses pixels. So we say that some shape sits at some pixel value on our screen, and we need some way to convert between these two. Now that's actually very simple. We can have a const expression or just some const value. Call it a float. I'll say this is going to be my pixels per meter, and I'll initialize this with 50. So that means that for every 50 pixels on my screen, there's going to be 1 meter in Box2D. So this gives us a conversion handle. Let's make a convenience method for this to convert these things. So I'll have an inline method here, and it's going to return an SF vector. This is the SFML type, and I'll need to remember to include some of this stuff. So SFML, I guess we can just include one of these index header files, and it's going to be an SF vector 2F. That's fine. B2, that stands for Box2D to SFML. And we need to pass in the Box2D equivalent. And for that, I'll need to do another include here. So include, we can do Box2D, and then simply include this header file. The vector type in here is called a B2 vec2. And I'll pass this in as a const reference. And now, in order to do the conversion, all of these vector types can be instantiated with this curly bracket notation. So that's fine. I'll take my Box2D vector, the X value there, times with the pixels per meter. So we say, if this Box2D vector sits at position 1 and 2, that means 1 meter to the right and 2 meters up, then that means that we move 1 meter to the right. And in our case, that's going to be 50 pixels. So we move 50 pixels to the right. And 2 meters up, that means we move 2 times 50 pixels up. So it's actually pretty easy to do the conversion. We just multiply the conversion value with those values coming in here. Now later on, we will need the reverse of this, but just to make it simple here, we can actually have that already. We say SFML to B2, pass in a const vector 2F, and now this one we can simply say return some vector value. If we take a look at this vector, it's going to say something like this thing sits at position 50 and 50. That's the pixel value. So if we want to take that back to meters, we simply need to divide with the pixels per meter. And that's it. So if we divide 50 by the pixels per meter, that'll give us 1. And if we divide the other 50 or 100 or whatever with the pixels per meter value, that'll give us the meter representation. And now we have the Box2D position from our SFML position. So this is enough to convert these values to and from.